Welcome back to Algebra 2, Chapter 6, Section 1. In this book, we are talking about exponents, and my handwriting up there is extra bad. Alright, you should know about exponents and eggs too by Algebra 2, but just in case you don't, let's talk about it. Let's talk about that. Okay, so if you have x to the fifth, that means you have 1, 2, 3, 4, 5 x's multiplied by each other. And then we multiply that by x to the fourth. 1, 2, 3, 4 x's multiplied. And because they are all the same base, we can count them and see how many we have, and we have 9. Now your book talks about you add them and then you divide when it's, so you subtract if it's divide. I'm going to show you an easier way to just think about it all, where these are super easy and you don't have to do it their way. Do it my way. I promise. It's better. I'm better. Okay, so this one. Here we have a parentheses. What does parentheses mean in algebra? It means multiply. So this literally means 2 times 3. And what is 2 times 3? 6. Okay, here's this one. Parentheses. If you have something outside the parentheses, what does it go for? Everything inside. Distributive property. So we just distribute that 3 and it's x to the third, y to the third. Now this one I want to take a little time with. If it is a negative exponent, I want you to think of it like the game Portal. I don't know if you've ever played it, but I'll tell you about it. It's a video game where you're a test subject in this facility and you're running around and you have a gun. And you can shoot holes in walls or ceilings or floors that make a portal for you to go through to the other level. So I want you to pretend this is a portal gun, but it's a little different than the one in the video game because it's only a one-time use gun. In the video game you can use your portal gun over and over again. It's really funny. You should play it if you haven't played it. Right now I am playing Animal Crossing, the new one that came out, and it's very fun. Alright, but back on track, away from the video games, back to this. I'm also playing Legend of Zelda, but I have to admit to you that I have to cheat. I cannot figure out the puzzles unless I go online and read, oh, I'm supposed to move that. Oh, anyway. Okay, so here's my portal gun, and it's going to shoot a hole in the wall. Well, where is the wall in math? It's the denominator bar. So it's going to take the gun and shoot it and make a portal. Let's make a bigger portal. Make a portal, and the exponent and its base drop through the portal. So this, but it's a one-time use thing, so here they are now in the basement, in the denominator land. What do you put in numerator land? Do we leave it blank? Of course not. Understood one. I'm back to saying that I kept saying imaginary when I meant understood one, but hopefully y'all understood that in the imaginary chapter. It was probably because I dislike imaginary numbers I was, doing that. Okay, what about if, say it was this. What if it was the negative exponent was in the denominator to start with? Then it's going to shoot the ceiling, it's going to make the portal, and it would pop up to numerator land 3. It'd pop up to numerator land, and so it can go up or down, just like in the game, but unlike the game, you can't go sideways with it. You can only go up and down. Also, if there had been a 2 here, it would not go. The gun is not strong enough to take anything else, just the base and the exponent. So then that 2 would have been left in denominator land, while x and the exponent would go up to numerator land. Okay? Anything raised to the 0 power is 1. Try it on your calculator. Kind of fun. Kind of fun little thing there. So it doesn't matter that it's an x, it's going to be 1. So put in your calculator, 14 to the 0 power, 1. Negative 4 to the 0 power, 1. Okay, now, if you have the same thing on top and bottom of a fraction, what are you allowed to do? Cancel out. One of my favorite things, because I like marking out math. I know it doesn't make sense, but deep down I think that I'm getting away with something, marking the math out. So I have 2 x's on bottom and 3 on top. These two mark out 2 of those, leaving 1. So all that I have left is an x in numerator land. What about this one? I've got 1 on top, 6 on bottom. This one marks out one of those, leaving a 5, so I have 1 over x to the 5th. Don't do that subtracting thing that they show you in the book. Just cross out. It's so much faster and more logical. But it has to be the same base. Okay, how about this? I have x over y to the 3rd power. Distributive property, anything outside parentheses goes for everything inside. So you distribute that 3 as x cubed over y cubed. How about this one? Now we're moving off of x's to the examples in the book. 3 times 4 is 12, 2 to the 12th power. Now sometimes on the exponent test, they want it left as an exponent and not put as a real number, because you can put this exactly on your calculator and it will give you the answer, the real number, the 4,000 thing, whatever it is in the book. So if you do beginning parentheses 2 to the 3rd power in parentheses to the 4th power, you will get the same thing that 2 to the 12th power is. So you just have to do whatever they tell you to do. If they say use your calculator, that's always easy. Alright, how about this one? This is going to distribute, so it's 3 squared over 4 squared, which is 9 over 16. Okay, so sometimes they want you to leave it like this, sometimes they want that. How about this? Okay, that if there's a negative exponent, I do all the shooting of the portal guns first. So I'm going to turn this into negative 5 to the 4th power over, pa-ching, off it goes down to the denominator. It got shot through the portal gun and down it went to the denominator. Now I can cross out because I have the same thing on top and bottom. These 4 can cross out 4 of those, leaving 2. So I'm left with 1 over negative 5 squared. And you have to put that in parentheses because it's negative, or else it'll do 5 squared times understood negative 1, which will give you the wrong sign. So this equals 1 over 25. Okay, how about this one? Well, I'm going to get rid of the negative, the portal gun first. So first thing I'm going to do is I'm going to have r still in the numerator, x comes up to the 5th power, and all of this is to the 2nd power. So it's r squared x 5 times 2 to the 10th. Okay, do you see how to do them? They're not terrible, are they? So what I'm doing first is I'm going to put this where it goes in denominator land. 7 gets to stay in numerator land, but I'm going to put, so this is 7 squared, and this is x to the 3rd power to the 2nd power, and then I have x to the 5th and x. And this is 3 times 2, which is 6. Now I can cross things out. I have 5 up here, those can cross out 5 of those. And then I have an x and an x, and those cross out too. It's hard to cross out x's because they're already an x. So I'm left with 7 squared, which is 49. Woo, that one was fun. Okay, how about this one? Okay, what am I doing first? I'm shooting the portal gun, and I'm putting this y up in numerator land. Did you follow me there? Now I'm going to distribute this. This is a 2 and this is going to be a 4. Now I would do this on paper on different lines. Now I can mark things out. I have 2 3s up here that can cross out 2 of these, leaving 1, and I have 4 and another one for y. So I have y to the 5th x. Okay, so the more you practice these, they really like this problem on the SAT, the ACT, college entrance exams, because they're fast and easy, and they show if you know how to use exponents. Now there's another concept in this chapter called scientific notation. And the reason why we have this is your calculator can do math on bigger and smaller numbers than the screen can display. So it's a shorthand way of writing numbers for your calculator to put them in. This is the form. It's one number, a decimal point, the rest of the non-zero numbers, times. And do you see what that times is? It's an x. And we've worked so hard in saying x is not time, x is an unknown variable until today. And now it's back as times. 10 to an exponent. This is how it works. So here's my decimal, and you notice he's a frog because he's going to frog hop to his proper place, and we're going to count how many frog hops he has. Ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this number is 1.23 times 10 to the 10th power. Let's do this one. 1, 2, 3, 4, 5, 6 is the right place. So this is 1.23 times 10 to the negative 6. Numbers that are super big have a positive exponent. Numbers that are super small, weigh less than 1, they're little bitty decimals, have a negative exponent. You have to be able to put these in your calculator, and you do not do 1.23 times 10 to up arrow 10. It will give you the wrong answer. I guarantee it. This is what you do. We're going to put this one into our calculator. On your calculator, on the regular screen, the math screen, do 1.23. Then you do second comma. The comma is right there, and painted above it in blue, in my calculator, is EE. That stands for exponential stuff. Some calculators have EXP. Some old calculators, Casio's, had SCI. They all mean scientific notation. So you do second comma, and it will put a little E there. That E stands for times 10. And then you put negative 6, and that is putting that number in your calculator. I want you to practice with your calculator, doing all the scientific notation stuff in the book. Got to get good at that calculator. I guarantee that too. Math is great.